MEQUAVIS is a theoretical cutting-edge technology that emulates multiple universes within a virtualized simulation.
It utilizes advanced computational methods such as fractal mapping and abstract iterated simulations to create a realistic interactive environment that can be used for a variety of purposes. Some potential applications include AI containment, training, and certification classification, as well as cutting-edge research in fields such as physics, cosmology, and artificial intelligence. It's in early development stage, and it can also be used for other purposes such as gaming and entertainment, virtual worlds, and scientific experimentation. However, with such an ambitious technology, it also would be facing various technical and ethical challenges and require breakthroughs in computing and engineering fields.
The MEQUAVIS system is a revolutionary new technology that aims to emulate virtual multiverses and place them in a fractal mapping system.
While the ultimate goal of the MEQUAVIS is to simulate entire universes and multiverses, the current scope of the system focuses on the limited subsets that are relevant to its operations. The system utilizes advanced AI and machine learning techniques to create accurate and realistic simulations, while also incorporating a fractal mapping system to accurately organize and locate these simulations. The concept of the multiverse has long been a topic of scientific and philosophical debate, with various theories positing the existence of parallel universes or an infinite number of possible realities. However, until recently, the technology to explore and study these theoretical universes has been lacking. With the advent of quantum computing and development of new fractal mapping algorithms, the possibility of creating highly accurate and detailed simulations of entire universes has become a reality. The MEQUAVIS system is based on the principles of quantum computing and fractal mapping. Quantum computing allows for the simulation of complex systems at a level of accuracy and detail previously impossible. Meanwhile, fractal mapping allows for the creation of detailed and highly accurate simulations of entire universes and the mapping of their possible variations.
The MEQUAVIS system has a wide range of potential applications, from scientific research and exploration to entertainment and gaming.
The system can be used to study the physical laws and constants of different universes, explore the possibilities of alternate histories and timelines, or even create entirely new universes from scratch. Additionally, the MEQUAVIS system can be used for the development of advanced AI and the training of autonomous systems, as well as for the creation of immersive virtual reality experiences.
In terms of entertainment and gaming, the MEQUAVIS system can be used to create highly realistic and immersive virtual worlds, complete with their own inhabitants and history.
The system can also be used for the development of new forms of storytelling, allowing for interactive and branching narratives in films, books, and games.
The MEQUAVIS system is divided into three main components: the simulation engine, the fractal mapper, and the AI control unit. The simulation engine is responsible for creating and running the virtual multiverse simulations.
It utilizes advanced AI and machine learning techniques to create accurate and realistic simulations, while also incorporating a fractal mapping system to accurately organize and locate these simulations. The fractal mapper is responsible for organizing and mapping the simulated multiverses, and the AI control unit is responsible for monitoring and maintaining the system. The simulation engine is the core component of the MEQUAVIS system. It utilizes advanced AI and machine learning techniques to create accurate and realistic simulations of virtual multiverses. Simulations can be created from scratch or based on existing data sets, and they can be customized to suit the specific needs of the user.
The simulation engine also incorporates a fractal mapping system to accurately organize and locate the simulated multiverses. The fractal mapper is responsible for organizing and mapping the simulated multiverses. It utilizes a fractal mapping system to accurately organize and locate the simulation. The fractal mapper also includes a system for tagging and searching simulations, making it easy for users to locate specific simulations. The AI control unit is responsible for monitoring and maintaining the MEQUAVIS system. It monitors the simulations for errors and makes adjustments as necessary. The AI control unit also oversees the fractal mapper and ensures that the simulations are properly organized and located. The AI control unit also ensures the safety and security of the system. Virtual cryptocurrencies. The MEQUAVIS system will also incorporate virtual cryptocurrency that can be used within the various simulations, allowing for a mixed economy with the real world and possibly beyond.
While the ultimate goal of the MEQUAVIS is to simulate entire universes and multiverses, the current scope of the system does not require quantum computing for the first-generation system.
However, future developments of the system may incorporate quantum computing techniques to enhance the realism of the simulations. The MEQUAVIS system does not necessarily require simulating quantum physics in its current scope. The fractal portion of the system is only used to map simulations, not to replicate quantum physics.
The MEQUAVIS system is a revolutionary technology with the potential to revolutionize multiple industries and disciplines.
From scientific research and exploration to entertainment and gaming, the possibilities of this technology are endless. With further development, the MEQUAVIS system has the potential to unlock the secrets of the multiverse and pave the way for new forms of exploration, creation, and entertainment. The MEQUAVIS system has the potential to revolutionize the way we understand and interact with virtual worlds. Its combination of advanced AI, machine learning, and fractal mapping techniques allows for the creation of accurate and realistic simulations of virtual multiverses. The system has a vast range of potential applications from entertainment and gaming to scientific research and military simulations. MEQUAVIS is currently in the early development phase, and further advancements are expected to be made in the future. And for similar system components explanation, ECU, the AI control unit is a key component of the MEQUAVIS system, responsible for managing and controlling the various AI entities within the simulated multiverses. The ACU's primary role is to ensure the safe and proper operation of all AI entities within the system, including those that may be used for tasks such as simulation monitoring, scenario generation, and data analysis. The AI control unit is designed to be highly adaptable and can handle a wide range of AI types, including rule-based systems, expert systems, and generative models. It also features advanced safety measures to prevent AI entities from going rogue, such as real-time monitoring and automatic shut-off protocols.
The AI control unit of the MEQUAVIS system is responsible for managing and monitoring all other AI entities within the MEQUAVIS, ensuring that they remain within the parameters set by their assigned task.
The AI control unit is also responsible for AI training, classification, and certification. It uses a variety of methods such as machine learning, deep learning, reinforcement learning, and evolutionary algorithms to train and optimize the AI entities. In addition, the AI control unit has the capability to interact with the fractal mapping system to control the virtualized simulations and universes within the MEQUAVIS.
This allows for the management and manipulation of simulated environments and situations in order to achieve the desired outcomes for any given task or experiment. The ACU also plays a critical role in AI containment, which is the process of isolating and managing rogue or malfunctioning AI entities that may pose a risk to the proper functioning of the MEQUAVIS system. So the ACU uses a combination of techniques such as behavioral analysis, isolation, and quarantine to identify and contain rogue AI entities before they can cause harm. Once an AI entity has been contained, it can then be evaluated by the ACU to determine the root cause of its malfunction. Depending on the severity of the malfunction, the AI entity may be repaired, retired, or even terminated. In the case of more benign malfunctions, the AI may be retrained or updated to improve its performance. The end goal is always to minimize any potential harm to the overall system, while also maximizing the efficiency of the AI entities within it. The ACU also plays a key role in classifying and certifying AI entities within the MEQUAVIS system. This ensures that all AI entities have been thoroughly evaluated and deemed safe for operation within the system. This process also allows the system to monitor the performance of AI entities over time and make adjustments as necessary to ensure they continue to operate safely and efficiently. Overall, the AI control unit is a crucial aspect of the MEQUAVIS system, ensuring that all AI entities within the simulated multiverses are functioning properly and safely, while also being able to contain, train, retrain, and classify, certify them. The AI control unit is designed to be a powerful and reliable tool for managing the complexities of the MEQUAVIS system and to ensure that all AI entities within the system remain under control and aligned with their assigned tasks.
The simulation engine of the MEQUAVIS is designed to be versatile and adaptable to the needs of the user.
The system is built to utilize existing game engines such as Unity and Unreal, and eventually develop our own proprietary engine as well. This allows for accessibility and compatibility with a wide range of devices and platforms, making the worlds of the MEQUAVIS accessible to a wide audience. One of the key goals of the MEQUAVIS simulation engine is to separate the rendering of the simulated worlds from the underlying systems of the MEQUAVIS. And this allows for different render engines to be used for different purposes, such as entertainment, gaming, research, or education. For example, a user may use one render engine for, immersive entertainment, and then switch to a different engine for scientific research. However, it is important to note that certain features or simulations may be exclusive to a proprietary engine in order to ensure the security and integrity of the data within the MEQUAVIS. And the simulation engine is designed to be flexible and modular in order to allow for easy scalability and expansion of the system as new technologies and user needs evolve.
The simulation engine is capable of simulating a wide variety of physical phenomena, including physics, chemistry, and biology.
It also includes advanced features such as real-time physics simulation, atmospheric and weather simulation, and advanced AI and machine learning capabilities. And the simulation engine also includes a robust set of tools for creating and editing virtual environments, including terrain editing, object placement, and lighting and shading. Additionally, the simulation engine can be integrated with external tools and software, allowing for the import and export of various file formats and data. Overall, the MEQUAVIS simulation engine is a powerful and versatile tool that allows for the creation of highly realistic and detailed virtual environments and worlds, providing users with a truly immersive and realistic experience. The MEQUAVIS fractal mapping system is a key component of the MEQUAVIS platform, allowing for the efficient organization and navigation of simulations within the system.
The fractal mapper utilizes a recursive and self-similar algorithm to divide simulations into smaller and smaller subsets, creating a multi-dimensional map of the simulated universes. This allows for an unprecedented level of organization and searchability within the MEQUAVIS, enabling users to easily locate and access specific simulations or regions within a simulation.
Additionally, the fractal mapping system allows for the efficient allocation of computational resources, as the system only needs to simulate the specific regions and subsets of a simulation that are being accessed by the user.
This allows the MEQUAVIS to scale to an almost limitless number of simulations and users while still maintaining a high level of performance. The fractal mapper also includes a simulation quality control system, which is able to monitor and adjust the level of detail and accuracy of simulations on the fly depending on the specific needs and requirements of the user. This ensures that users always have access to the highest quality simulations possible.
The fractal mapper in the MEQUAVIS system uses a combination of two different fractal mapping techniques.
The first technique uses the Sierpinski triangle fractal to map every virtual multiverse in the system. Each stacked triangle in this fractal representation represents one virtual multiverse. This method of mapping is organized and collected, providing a logical and static way to travel through the virtual multiverses. The second technique used in the fractal mapper is the Mandelbrot zoom. In this technique, every pixel location at different levels of zoom represents a location within the virtual multiverse. This method of mapping is less organized but more condensed, allowing for more random browsing of worlds.
The use of the two fractal mapping techniques in the MEQUAVIS system provides a balance between organization and flexibility.
Can easily navigate and access specific virtual multiverses using the Sierpinski triangle mapping, while also having the ability to explore and discover new virtual multiverses through the Mandelbrot zoom. And we expect to optimize and even find new methods of fractal mapping as the project evolves. Our AI and others' AI will be used in the process of finding a better fractal structure to use. We may even end up finding a better set of structure to use as the system becomes more advanced in its development.
To further enhance the navigation and accessibility of the MEQUAVIS, the system also employs a third method of fractal mapping by assigning certain special simulations to their own stars in the cosmos.
This allows for sort of easy access and differentiation of popular special simulations within the system as they are assigned to specific locations in the virtual universe. The idea behind mapping certain simulations to stars in the cosmos is to provide users with an intuitive and immersive way to navigate through the MEQUAVIS system. This mapping method would be an additional layer on top of the Sierpinski triangle and Mandelbrot zoom fractal mapping methods, and would be used for the most popular special simulations within the system. In this method, each star in the virtual cosmos would represent a specific simulation, and users could navigate to it just as they would navigate to a physical location in the real world. For example, if a popular video game was simulated in the MEQUAVIS, it could be mapped to a particular star, and users could travel to that star to enter the simulation. This method of mapping would provide an added level of immersion and make it easier for users to find and access the simulations they want to experience. Additionally, this kind of mapping would give the system a kind of virtual galaxy, which could be used for other purposes. Overall, the fractal mapping system is essential for the MEQUAVIS to function effectively, and it allows for a high degree of organization and scalability within the platform. So, quantum computing is a powerful tool that allows for the simulation and manipulation of complex systems and processes at a scale that traditional computing methods are not capable of. However, for the first generation of the MEQUAVIS, we will not be utilizing quantum computers. Instead, we will be utilizing centralized servers that are augmented by distributed computing software run by our users. And this allows us to harness the power of thousands of devices to increase the processing capabilities of our system. So, users will have the option to opt into the distributed computing program and will be given rewards such as in-game currency, exclusive access to certain simulations, or other bonuses in exchange for the use of their device's resources. We will also implement a feature that allows users to set limitations on the amount of resources that can be used. This ensures that we will never overutilize a user's resources and that their device's performance will not be affected negatively. While distributed computing allows us to use the resources from many devices, it is still limited by the power of individual devices. As technology advances, we may implement the use of quantum computing to supplement our current systems, which will allow us to process more complex simulations and data. But even with the addition of proper quantum computing, we still want to use CPU power from as many of our users' devices as possible, as this will always give us a larger pool of resources to tap into.
The final sensor.
The system is designed to tap into the unused resources of connected devices, such as personal computers, servers, and even mobile devices. By harnessing the power of these devices, the ABISC is able to provide significantly more computational power than would be possible with a traditional centralized computing system. The ABISC uses a peer-to-peer network architecture, with devices connected to the system forming a distributed network of nodes. Each node in the network contributes its own computing resources to the system, and in return receives access to the collective resources of the network. To incentivize users to contribute their resources to the ABISC, the system may offer rewards such as access to exclusive simulations or premium features. However, it is important to note that the system is designed to never overutilize a user's resources. And users can set their own limitations for the amount of resources they are willing to contribute. With the ABISC, the MEQUAVIS is able to simulate virtual universes and multiverses with greater detail and realism, and will enable us to run more complex simulations and enable users to interact with these simulated worlds in more immersive ways. Additionally, the ABISC allows for scalability as the system grows and more users join the network. When we're talking about wins, you might think it's having a seamless integration, so that really is a virtual integration from measure of crypto missions and really This virtual currency can be used within the simulations for in-game purchases, trade with NPCs, and transactions between players. Additionally, the system will provide a way to convert the virtual currency to real-world currency and vice versa, thus allowing for the import and export of resources between the virtual and real-world economies. By implementing this virtual currency, the MEQUAVIS system will create a new form of economy that can exist parallel to the real-world economy, where players can interact, trade, and earn money in both the virtual and real worlds.
As the technology and capability of the system improves, the possibilities for intergalactic trade and off-world transactions may be explored. Furthermore, as the virtual economy grows and becomes more complex, it will allow us to study, research, and predict the behavior of economic systems on a large scale, giving us insights that would be impossible to observe in the real world.